A formation of B-17 bombers drones eastward toward Germany at 25,000 feet, their contrails marking white lines across the cold blue sky. Below them, somewhere in occupied France or Belgium, German fighter controllers are tracking their progress on radar, scrambling squadrons of Messerschmitt and Focke-Wulf fighters to intercept. The bomber crews know what is coming. For the past year, 1943, this has been the pattern. The short-range P-47 Thunderbolt fighters that escorted them from England have already turned back, reaching the limit of their fuel supply. Now the bombers are alone, deep in enemy territory, still hundreds of miles from their target. German fighters will hit them soon, attacking in waves, and the losses will be heavy. Some bomber crews are flying their first mission. Many are flying their last. But today, something is different. As the first German fighters appear, diving down from above, another formation appears. Sleek, silver fighters with long noses and distinctive belly scoops, moving fast, climbing to meet the German interceptors. The bombers, gunners, tense and ready for the onslaught, hear their radio crackle to life. The new fighters identify themselves, Mustangs, P-51 Mustangs, and they have fuel to stay with the bombers all the way to Berlin and back. For the first time in the strategic bombing campaign against Germany, the bombers will not fly alone into the heavily defended heart of the Third Reich. This changes everything. The strategic bombing campaign that the United States Army Air Forces launched against Germany in 1942 and 1943 was based on a doctrine that had been developing since the 1920s and 1930s. American military theorists believed that strategic bombing, the systematic destruction of an enemy's industrial capacity and infrastructure, could win wars without the need for massive ground campaigns. The idea was that bombers, flying at high altitude and armed with precision bomb sights, could destroy specific factories, refineries, rail yards, and other strategic targets, crippling the enemy's ability to wage war. Furthermore, these theorists believed that bombers, particularly if they were heavily armed, could fight their way to targets and back without fighter escort. This doctrine was put to the test when American bomber forces began operations from England in 1942. The early missions were small-scale and targeted objectives in occupied France, relatively close to England, where fighter escorts could provide coverage. These missions showed promise. The Norden bomb sight, a sophisticated analog computer that calculated the bomb release point based on altitude, speed, wind, and trajectory, allowed for accurate bombing when conditions were right. The B-17 Flying Fortress, and later the B-24 Liberator, both heavily armed with .50 caliber machine guns, showed they could defend themselves to some degree. But as the campaign expanded and bombers began striking targets deeper in Germany, the limitations and flaws of the doctrine became brutally apparent. German fighter defenses were formidable. The Luftwaffe had skilled pilots, excellent aircraft like the Bf-109 and FW-190, and they developed tactics specifically designed to break up bomber formations and destroy as many bombers as possible. The Germans would attack from head-on, closing at combined speeds of over 500 miles per hour, their cannons and machine guns blazing. They would attack from above and below, exploiting blind spots in the bombers' defensive coverage. They would focus their attacks on bombers that had already been damaged or that had fallen out of formation, knowing that stragglers were easier to destroy. The losses were catastrophic. On August 17, 1943, the 8th Air Force launched a major raid against the ball-bearing factories in Schweinfurt and the Messerschmitt factory in Regensburg. These were deep penetration raids into southern Germany, beyond the range of available fighter escorts. Of the 376 bombers that attacked, 60 were shot down and another 87 were damaged, many so badly they never flew again. That is a loss rate of nearly 16% in a single day. With losses like that, the entire bomber force could be destroyed in just a few months of operations. The second raid on Schweinfurt, on October 14, 1943, was even worse. Of 291 bombers that penetrated German airspace, 77 were shot down and 121 were damaged. The loss rate was over 26%. This mission became known as Black Thursday, and it effectively proved that unescorted daylight bombing deep into Germany was not sustainable. The 8th Air Force temporarily halted deep penetration raids, acknowledging that without fighter escort, they simply could not continue the campaign. The problem was fighter range. The fighters available to the 8th Air Force in 1943 were excellent aircraft for their intended roles, but they did not have the range to escort bombers deep into Germany. The P-47 Thunderbolt was a powerful, heavily armed fighter, but even with external drop tanks, its combat radius was only about 300 miles. That meant it could escort bombers partway into Germany and then had to turn back to reach England before running out of fuel. The Spitfire, used by the Royal Air Force and also available to some American units, had even less range. What was needed was a fighter that could match the performance of German fighters in combat, which meant it needed speed, maneuverability, climb rate, and firepower, but also had the range to stay with the bombers all the way to targets deep in Germany and back, a round trip of 1,000 miles or more. That fighter already existed, but it was not yet recognized for what it could become. The P-51 Mustang had been developed in 1940, not for the American military, but for the British. The Royal Air Force, desperate for fighters during the Battle of Britain and its aftermath, approached North American aviation to build P-40 fighters under license. North American proposed instead to design an entirely new fighter and remarkably promised to have a prototype flying in just 120 days. This was an incredibly ambitious timeline. Most fighter development programs took years, but North American had a talented design team led by James Kindleberger and Edgar Schmude, and they had been studying fighter design extensively, learning from both American and European approaches. The team worked around the clock, and they delivered. The prototype, designated the US-73, flew for the first time in October 1940, just 102 days after the contract was signed. This was an extraordinary achievement in aircraft design and manufacturing. The Mustang, as it was named by the British, was an impressive aircraft from the start. It had a streamlined fuselage and a laminar flow wing, a relatively new design concept that reduced drag significantly. The wing was designed so that air flowing over it would remain smooth and laminar rather than turbulent, which reduced drag and increased efficiency. This gave the Mustang excellent speed and range. However, the early Mustang had a significant problem. It was powered by an Allison V-1650 engine, an American liquid-cooled V12 that produced about 1,150 horsepower. This engine performed well at low altitudes, but lost power rapidly above 15,000 feet because it lacked an efficient supercharger. The Allison engine had a single-stage, single-speed supercharger that could not maintain manifold pressure at high altitudes. Since combat at altitude was crucial for air superiority and bomber escort, this was a serious limitation. The early Mustangs were used by the RAF for low-altitude tactical reconnaissance and ground attack missions, where they performed well, but they were not suitable for high-altitude combat against German fighters. The transformation of the Mustang from a good low-altitude fighter to arguably the best all-around fighter of World War II came through the marriage of the Mustang airframe with the British Rolls-Royce Merlin engine. The Merlin was a superb engine that powered the Spitfire and the Hurricane, two of the most famous fighters of the Battle of Britain. The Merlin had a two-stage, two-speed supercharger that maintained power output at high altitudes. There is some debate about exactly who first proposed this combination, had the idea of installing a Merlin engine in a Mustang. The British tested this combination first, installing a Merlin 61 engine in Mustang airframes in late 1942. The results were spectacular. The Merlin-powered Mustang had excellent performance at all altitudes. It was fast, with a top speed of over 440 miles per hour at 25,000 feet, making it one of the fastest fighters of the war. It could climb quickly to altitude. It was maneuverable, able to turn and fight with German fighters. And crucially, it had range. The efficient laminar flow wing and the fuel-efficient Merlin engine, combined with internal fuel capacity and the ability to carry external drop tanks, gave the Mustang extraordinary range. The American aircraft industry began producing Merlin engines under license, with the Packard Motor Car Company manufacturing them as the Packard V-1650. The P-51B, the first production model of the Merlin-powered Mustang, began reaching 8th Air Force units in England in late 1943. The timing was critical. This was right after the disastrous October raids that had shown the unsustainability of unescorted deep penetration bombing. The P-51 was exactly what the 8th Air Force needed, arriving at exactly the right moment. The specifications of the P-51B and the later P-51D, which became the most numerous variant, were impressive across the board. The aircraft was powered by the Packard V-1650 Merlin engine, producing 1,490 horsepower. Later versions produced even more. The engine drove a four-bladed propeller. The aircraft weighed about 7,000 pounds empty and had a maximum takeoff weight of around 11,600 pounds with full fuel and external tanks. It had a wingspan of 37 feet and a length of 32 feet. The fuselage was sleek and streamlined, built around the engine with the cockpit positioned well back, giving the Mustang its distinctive long-nosed appearance. The wing design was one of the Mustang's great strengths. The laminar flow airfoil was designed by North Americans aerodynamicists to minimize drag. In theory, a laminar flow wing maintains smooth, non-turbulent airflow over a larger portion of the wing surface than conventional airfoils. In practice, achieving true laminar flow was difficult because it required extremely smooth surfaces and operational aircraft in the field, with dirt, bugs, and wear on the paint, rarely achieved perfect laminar flow. However, even without perfect laminar flow, the wing design was very efficient and gave the Mustang excellent speed and range. The internal fuel capacity of the P-51B was about 180 gallons in tanks located in the fuselage behind the cockpit. The P-51D increased this to 269 gallons by adding fuel tanks in the wings. In addition to internal fuel, the Mustang could carry external drop tanks. These were expendable fuel tanks that could be jettisoned when empty or when the pilot needed to maneuver for combat. 2 drop tanks could be carried, one under each wing. Early in the deployment of the P-51, these were typically 75-gallon or 108-gallon tanks. Later, 110-gallon and even 150-gallon tanks were used. With 2 108-gallon drop tanks and internal fuel, a P-51 could carry over 400 gallons of fuel. This gave the aircraft a combat radius, the distance it could fly out, fight for a period of time, and return of over 650 miles. With the larger drop tanks and careful fuel management, this could be extended even further, allowing the P-51 to escort bombers to Berlin, over 600 miles from bases in England and back. The armament of the P-51 varied slightly between models. The P-51B and P-51C had 4.50 caliber machine guns, 2 in each wing. The P-51D, which had a redesigned wing and the famous bubble canopy that gave the pilot all-around visibility, had 6.50 caliber machine guns, 3 in each wing. The .50 caliber Browning machine gun was an excellent aircraft weapon. It had good range, good accuracy, and fired a heavy bullet that could do significant damage. The rate of fire was about 800 rounds per minute per gun, so a P-51D with 6 guns was putting out 4,800 rounds per minute when all guns were firing. Of course, the ammunition supply was limited. Each gun had about 400 rounds in the early models and about 270 rounds in later models, giving about 30 seconds of fire time. This meant that pilots had to aim carefully and fire in short bursts to conserve ammunition. The .50 caliber rounds used in aerial combat came in several types. Ball ammunition was standard, solid bullets designed for penetration. Armor-piercing incendiary rounds had a hardened core to penetrate armor and a small incendiary charge that would ignite on impact. These were effective against fuel tanks and engines. Tracer rounds had a pyrotechnic charge in the base that burned brightly, allowing the pilot to see where his shots were going and to adjust his aim. Typically, ammunition belts were loaded with a mix of these round types to provide versatility. The Mustang's performance in air-to-air combat was outstanding. It could reach its top speed of over 440 miles per hour at high altitude, and it was fast at all altitudes. It could climb to 20,000 feet in about 7 minutes, which was competitive with German fighters. Its service ceiling, the maximum altitude it could effectively operate at, was over 41,000 feet, higher than most German fighters could reach. In terms of maneuverability, the Mustang could turn with most opponents, though some aircraft like the Spitfire could outturn it in sustained turns. However, the Mustang excelled in high-speed maneuvers and in boom and zoom tactics, diving on an enemy, attacking, and then climbing away using superior speed and energy. The visibility from the P-51D's bubble canopy was exceptional. Earlier fighters, including the P-51B, had a metal-framed canopy with a structure behind the pilot's head that created a blind spot to the rear. This was a significant disadvantage in combat because many attacks came from behind, and a pilot who could not see an attacker had little chance to evade. The bubble canopy eliminated this blind spot, allowing the pilot to see in almost all directions just by turning his head. This greatly improved situational awareness and survival in combat. The Mustang's control characteristics were generally good. It was responsive without being twitchy, and it was stable in flight. The controls were harmonized, meaning that the stick and rudder forces were balanced in a way that felt natural to pilots. However, the Mustang did have some quirks and limitations. One issue was that with full internal fuel and the rear fuselage tanks filled, the center of gravity shifted aft, making the aircraft less stable and more prone to entering a spin. Pilots were instructed to burn fuel from the rear fuselage tank first before engaging in combat. Another issue was that at very high speeds, the Mustang's ailerons became heavy and difficult to move, limiting roll rate in high-speed dives. This was a characteristic of the wing design and could not be easily changed. The deployment of the P-51 to the 8th Air Force in late 1943 and early 1944 came at a critical time. The bomber campaign had been stalled by losses, and there was pressure from multiple directions. The Soviet Union was demanding that the Western Allies do more to take pressure off the Eastern Front, where the Soviets were bearing the brunt of the ground war against Germany. Political leaders in the United States and Britain had promised a strategic bombing campaign that would cripple German war production. But the losses in unescorted raids had shown this was not achievable without fighter escort. The first P-51B groups arrived in England and began operations in December 1943. Initially, they were used for shorter-range missions as pilots and ground crews familiarized themselves with the new aircraft. But by early 1944, the P-51s were flying deep escort missions, going all the way to the target with the bombers and back. The impact was immediate and dramatic. In March 1944, the 8th Air Force launched a series of raids that became known as Big Week, a coordinated campaign targeting German aircraft production facilities. The P-51 Mustangs provided escort throughout these missions, flying to targets in central and southern Germany. The bombers still took losses from flak, which the fighters could not prevent, but the losses to fighter attacks dropped significantly. German fighters found that when they tried to attack the bomber formations, they had to fight through the American escorts first, and the P-51s were more than capable of winning those fights. The effect on the Luftwaffe was devastating. German fighter pilots had become accustomed to attacking bombers with relative impunity, using tactics refined over months of combat. They would form up in large formations, position themselves for attacks, and then dive through the bomber boxes, firing their cannons and machine guns. With fighter escorts present all the way to the target, this became far more dangerous. German pilots had to engage the escorts, and in those engagements, the Germans began to lose pilots at an unsustainable rate. The Luftwaffe's problem was multifaceted. By 1944, Germany was losing experienced pilots faster than they could be replaced. Training programs were shortened due to fuel shortages and the need to get pilots into combat quickly. This meant that new German pilots arrived at frontline units with less experience and less skill than the veterans they were replacing. In contrast, American pilots were generally well trained, and as the war progressed, many of them gained significant combat experience. A veteran American pilot in a P-51 was a formidable opponent, and even newer American pilots, flying in formations and following good tactics, could hold their own against all but the most skilled German pilots. The Mustang had performance advantages that made it deadly in combat. Its speed allowed it to choose when to engage and when to disengage. If a German pilot got into trouble, he could not necessarily run away because the Mustang could catch him. The range meant that Mustangs could hunt for German fighters, pursuing them even if they tried to avoid combat by diving away or heading for their bases. The good visibility from the bubble canopy meant American pilots could spot threats early and respond appropriately. Tactically, American fighter pilots adopted aggressive tactics. Rather than staying rigidly close to the bombers, which limited their ability to maneuver and hunt for German fighters, the P-51 pilots were given more freedom to range ahead of the bombers, to the sides, and even behind, looking for German fighters forming up for attacks. They would engage the Germans before they could attack the bombers, breaking up the German formations and forcing them into individual dogfights where superior American numbers and the performance of the P-51 gave the Americans the advantage. One of the key tactical developments was the fighter sweep, where groups of P-51s would fly ahead of the bomber stream, deliberately seeking out German fighters and engaging them far from the bombers. These sweeps forced the Germans to respond, and they bled German fighter strength through attrition. Every German fighter shot down in these engagements was one less fighter available to attack bombers later. American pilots also began to strafe German airfields. The long range of the P-51 meant that after escorting bombers to the target and back, the fighters often still had fuel remaining. Rather than just flying home, the P-51s would drop down to low altitude and attack German airfields, destroying aircraft on the ground, damaging facilities, and forcing the Germans to divert resources to airfield defense. These strafing attacks were dangerous because German airfields were defended by anti-aircraft guns, and flying low and slow made the P-51s vulnerable. However, the damage inflicted was significant, and it further depleted German fighter strength. The numbers tell the story of the P-51's impact. In 1943, before the P-51 arrived in numbers, the 8th Air Force lost over 1,000 heavy bombers to enemy action. In 1944, with P-51 escorts available, losses dropped significantly even as the number of missions and the depth of penetration increased. The Luftwaffe's fighter force, which had about 1,000 operational fighters defending Germany in early 1944, was systematically destroyed over the following months. By D-Day in June 1944, the Luftwaffe could barely contest Allied air superiority over France, in part because so many fighters and pilots had been lost in the battles over Germany against the combined bomber and escort fighter offensive. German commanders recognized the impact of the P-51. Adolf Galland, one of Germany's top fighter aces and the general of the fighter arm, reportedly said that when he saw P-51s over Berlin, he knew the war was lost. This might be somewhat apocryphal or exaggerated in the retelling, but the sentiment reflects the reality. If American fighters could operate over Berlin, deep in the heart of Germany, and if the Luftwaffe could not stop them, then Germany had lost air superiority, and without air superiority, Germany could not win the war. The first American fighter mission to Berlin was flown on March 4, 1944, and it was conducted by P-51 Mustangs of the 354th Fighter Group. They escorted bombers to Berlin and back, a round trip of over 1,200 miles, proving that the P-51 had the range to reach any target in Germany. This mission was a psychological shock to the Germans. Berlin, the capital of the Third Reich, was supposed to be protected by the vaunted Luftwaffe. Hermann Göring, the commander of the Luftwaffe, had famously promised that no enemy bombers would ever reach Berlin. Now not only were bombers reaching Berlin regularly, but American fighters were escorting them, engaging German fighters over the capital and flying home afterward. The operational procedures for long-range escort missions were complex and required careful planning and coordination. Bomber formations would take off from bases across England and form up into large combat boxes, with dozens or even hundreds of bombers in a single formation. Fighter groups would take off and climb to altitude, timing their departure to rendezvous with the bombers at specific points along the route. Different fighter groups would provide escort for different portions of the mission, handing off responsibility as fuel states required some groups to turn back. With the P-51's long range, some groups could fly the entire mission with the bombers, but even then, careful fuel management was essential. Pilots had to monitor their fuel consumption constantly. They knew how much fuel they started with, how much they were burning per hour at various power settings, and they had to calculate whether they had enough fuel to make it home. Running out of fuel over Germany or even over the English Channel meant ditching the aircraft or bailing out, neither of which were appealing prospects. Drop tanks extended range significantly, but they had to be jettisoned before entering combat because they created drag and made the aircraft less maneuverable. The decision of when to drop tanks involved balancing the need for range against the need for combat readiness. Navigation was another challenge. Formations of hundreds of aircraft flying through clouds and weather, with limited radio communication to avoid giving away positions to the Germans, had to stay together and find their way to the target and back. Navigational errors could separate formations, leaving elements lost or exposed. The Germans would use radio deception, giving false orders on American frequencies to try to confuse formations. Weather over Europe was often poor, with clouds, rain, and icing conditions that made flying difficult and dangerous. The human factor in these missions cannot be understated. Fighter pilots flew at high altitude, often above 25,000 feet, where temperatures were far below zero. They wore heated flight suits, but if the heating failed, frostbite was a real danger. They breathed oxygen through masks for hours at a time. They had to maintain intense concentration, constantly scanning the sky for enemy fighters, monitoring their instruments, maintaining formation with other friendly aircraft, and managing their fuel. Combat, when it came, was sudden and violent, with aircraft closing at high speeds, guns firing, aircraft tumbling out of the sky trailing smoke and flames. The psychological stress was immense. Fighter pilots knew that every mission could be their last. They saw friends shot down, sometimes seeing the aircraft explode with no parachutes, sometimes seeing parachutes, but knowing the pilot would become a prisoner of war if he survived the descent. They felt the weight of responsibility for the bomber crews they were escorting, knowing that if they failed to stop German fighters, bombers would be destroyed, and 10 men per bomber would die or be captured. Yet they also experienced the exhilaration of combat. There is something primal about aerial combat, about maneuvering your aircraft to get behind an enemy, about the moment when you have a clear shot and squeeze the trigger and see your tracers strike home. Fighter pilots were young, most in their early 20s, and they were flying high-performance aircraft in combat. The adrenaline, the skill required, the life-and-death stakes, all of this created intense experiences that marked these men for life. The aces, the pilots who shot down 5 or more enemy aircraft, became famous. The 8th Air Force produced numerous aces, and many of them flew P-51 Mustangs. Pilots like Don Gentile, John Godfrey, and George Preddy became well known for their scores. The Army Air Forces publicized their exploits to boost morale at home and to give the public heroes to root for. These aces were skilled pilots who combined natural talent with experience and aggressive tactics. They had excellent eyesight, allowing them to spot enemy aircraft at long distances. They were good marksmen, able to track a maneuvering target and lead it correctly to hit it. They understood energy management, knowing when to dive to gain speed and when to climb to gain altitude advantage. However, focusing too much on individual aces can give a misleading picture. The vast majority of the aerial victories and the suppression of the Luftwaffe came from the collective efforts of hundreds of fighter pilots, most of whom never became aces, but who flew mission after mission, engaging enemy aircraft when they encountered them, escorting bombers faithfully, and surviving to fly again. It was the cumulative effect of all these missions and all these pilots that destroyed the Luftwaffe's fighter force and won air superiority over Germany. The maintenance and logistics required to keep the P-51 force operational were enormous. Each aircraft required regular maintenance, including engine changes after a certain number of hours, inspections and repairs of battle damage and wear. Ground crews worked in all weather, often in the cold and mud of English airfields, to keep the aircraft flying. They performed engine changes, repaired damaged aircraft, replaced worn parts, and conducted pre-flight inspections before every mission. Their work was essential, and the high operational readiness rates of P-51 squadrons were a testament to their skill and dedication. Spare parts and replacement aircraft had to be shipped from the United States, a complex logistical operation involving cargo ships, ports, rail transport, and distribution to airfields. Fuel, ammunition, and other consumables had to be supplied in vast quantities. Each P-51 used about 100 gallons of high-octane aviation fuel per hour of flight, so a mission of 4 or 5 hours required 400 to 500 gallons per aircraft. With hundreds of aircraft flying missions regularly, the fuel consumption was staggering, and all of that fuel had to be shipped across the Atlantic and distributed to the airfields. The P-51 was not only used by the 8th Air Force in England. The 9th Air Force, which supported ground forces and provided tactical air support, also used P-51s. The 15th Air Force, based in Italy and bombing targets in southern Germany, Austria, and the Balkans, flew P-51s as well. In the Pacific theater, P-51s were used by the Army Air Forces, though less extensively than in Europe, because the distances in the Pacific often exceeded even the Mustang's range, and the P-38 Lightning, with its twin-engine redundancy, was often preferred for long overwater flights. The strategic impact of the P-51 extended beyond the direct combat effects. By gaining air superiority over Germany, the Allies ensured that the Luftwaffe could not effectively interfere with the D-Day landings or with subsequent ground operations in France and Germany. German ground forces had to operate under constant threat of air attack, with Allied fighter bombers attacking vehicles, trains, bridges, and troop concentrations. This significantly degraded German combat effectiveness and mobility. The loss of air superiority also affected German morale. German civilians experienced increasingly heavy bombing with little sign of effective defense. German soldiers on the ground rarely saw Luftwaffe aircraft, but constantly saw Allied planes. The propaganda claim that the Luftwaffe was protecting Germany became obviously false, which undermined confidence in the Nazi leadership. The production of the P-51 was a massive industrial effort. North American aviation's factories produced over 15,000 P-51s during the war, an extraordinary number for such a complex aircraft. This production was possible because of American industrial capacity, efficient manufacturing processes, and a large workforce. The factories operated multiple shifts, and workers, many of them women taking on roles in heavy industry for the first time, assembled the aircraft with remarkable speed and quality. The cost of a P-51D was about $50,000 in 1945 dollars, which is roughly equivalent to $800,000 in today's money when adjusted for inflation. This was expensive, but not prohibitively so given the aircraft's capabilities. Compare this to the cost of a B-17, which was over $200,000, or the cost of training a bomber crew and then losing them when their aircraft was shot down. The P-51 was a cost-effective investment in winning air superiority. The evolution of the P-51 continued throughout the war. The P-51D, with its bubble canopy and 6 guns, became the standard model. Later variants included the P-51H, a lightweight version with improved performance, but it arrived too late to see significant combat in World War II. There were also variants designed for photo reconnaissance, designated F6, which had cameras installed and were used for gathering intelligence. After World War II, the P-51 continued in service with the United States Air Force and with many Allied air forces. It saw combat in the Korean War, where it was used primarily for ground attack missions because jet fighters had taken over the air superiority role. The P-51 remained in service with some air forces into the 1980s, though by then it was relegated to second-line duties. Today, many P-51s are preserved in museums or are maintained in flying condition by warbird enthusiasts, and they remain popular at air shows where their distinctive sound and graceful appearance continue to draw crowds. The legacy of the P-51 Mustang extends far beyond its impressive combat record. It represented a high point in piston-engine fighter design, combining speed, range, altitude performance, and firepower in a single airframe. It demonstrated the importance of fighter escort for strategic bombing, a lesson that influenced post-war military doctrine. It showed that air superiority could be won through a combination of superior equipment, good tactics, and aggressive employment. For the bomber crews who flew missions over Germany in 1944 and 1945, the sight of P-51s overhead was enormously reassuring. They knew that the fighters would do everything possible to keep German interceptors away from the bombers. When they saw German fighters approaching, they also saw P-51s diving to engage them. When they returned from missions, bomber crews often expressed gratitude to the fighter pilots who had escorted them, recognizing that the fighters' presence had saved their lives. The fighter pilots themselves developed a strong sense of mission. They knew that their job was to protect the bombers, and they took that responsibility seriously. There was some tension between the desire to shoot down enemy aircraft, which brought personal glory and advancement, and the need to stay with the bombers and ward off attackers without necessarily pursuing them for individual kills. Good leaders emphasized that the mission was to bring the bombers home safely, and that meant staying in position to intercept threats rather than chasing individual German fighters across the sky. The partnership between the bombers and the P-51 escorts created a synergy that was greater than the sum of its parts. The bombers could destroy targets that ground forces could not easily reach, degrading German war production and infrastructure. The fighters ensured that the bombers could reach their targets and return, making the bombing campaign sustainable. Together, they imposed a multifaceted threat that Germany could not counter. German industry had to be dispersed to avoid bombing, which reduced efficiency. German fighters had to engage Allied escorts, suffering heavy losses. German resources had to be devoted to air defense, including anti-aircraft guns and fighters, which meant those resources were not available for the Eastern Front or for defending against the eventual Allied invasion of France. The technological innovations in the P-51, particularly the laminar flow wing and the careful attention to aerodynamic efficiency, influenced post-war aircraft design. Designers learned that reducing drag was crucial for achieving high performance, and the methods used in the P-51 were studied and refined. The success of the Merlin engine installation showed the value of international collaboration and technology sharing among allies. The pilots who flew the P-51 in combat came from all across the United States and beyond. Some were farm boys from the Midwest, some were city kids from New York or Los Angeles, some were college-educated, some had barely finished high school. What they shared was a desire to serve, the ability to pass the rigorous selection process for pilot training, and the courage to face combat. The Army Air Force's training program took civilians and turned them into military pilots in about a year, teaching them to fly increasingly complex aircraft and preparing them for combat. It was an expensive and time-consuming process, which made every pilot a valuable asset whose loss represented a significant investment. When pilots were shot down over Germany and survived, they either evaded capture and made their way back to Allied lines, were hidden by resistance groups and smuggled out, or were captured and spent the rest of the war in prisoner of war camps. The German treatment of captured Allied airmen was generally in accordance with the Geneva Convention, though conditions in the camps were harsh, especially in the final months of the war as Germany's infrastructure collapsed. Pilots who evaded capture had harrowing experiences, moving by night, hiding during the day, dependent on the courage of civilians who risked their lives to hide and feed them. The story of the Tuskegee Airmen, the African-American pilots who flew with distinction in the war despite facing segregation and discrimination, is an important part of the P-51's history. The Tuskegee Airmen flew P-51s with the 15th Air Force in Italy, escorting bombers on missions over Europe. They compiled an outstanding combat record and earned numerous decorations. Their success helped to challenge racial prejudices and contributed to the eventual integration of the U.S. military. They flew the same aircraft and faced the same dangers as their white counterparts, and they proved conclusively that skill and courage in combat had nothing to do with race. The strategic bombing campaign, enabled by the P-51's long-range escort capability, remains controversial among historians. Some argue that it was essential to defeating Germany, that it destroyed critical industrial capacity and forced Germany to divert resources to air defense. Others argue that it was less effective than claimed, that German production actually increased through 1944 despite the bombing, and that the campaign diverted resources that could have been used more effectively elsewhere. What is clear is that by 1945, Germany's transportation network was shattered, oil production was severely curtailed, and many cities and industrial areas were heavily damaged. Whether this could have been achieved more efficiently is a question historians continue to debate. What is not debatable is that the P-51 Mustang was instrumental in winning air superiority over Germany, and that without that air superiority, the Allied victory in Europe would have been much more difficult and costly. The Mustang allowed the strategic bombing campaign to continue. It protected the lives of thousands of bomber crewmen who would have been lost in unescorted raids, and it destroyed German fighter strength through attrition in combat. It was not a wonder weapon that single-handedly won the war, but it was a crucial tool that enabled the Allies to implement their strategy. The men who designed the P-51, particularly Edgar Schmude and his team at North American Aviation, created one of the most successful aircraft in history. They combined existing technologies, the laminar flow wing, the Merlin engine, efficient aerodynamics, in a package that was more than the sum of its parts. The men who built the P-51 in factories across America produced over 15,000 aircraft with impressive quality and speed. The men who maintained the P-51 in the field kept them flying under difficult conditions, and the men who flew the P-51 in combat took an excellent aircraft and used it to accomplish extraordinary things, flying hundreds of miles into enemy territory, fighting and winning against skilled opponents, and bringing themselves and the bombers they escorted home safely. In the final analysis, the P-51 Mustang changed World War II by solving a critical problem: the inability to escort bombers deep into Germany that had threatened to derail the strategic bombing campaign. It restored the viability of daylight bombing, it won air superiority over Germany, and it helped to set the conditions for Allied victory. More than a technological marvel, though it certainly was, that the P-51 was a war-winning weapon system because it arrived at the right time, in sufficient numbers, in the hands of capable pilots, and was employed according to sound doctrine. It was the combination of all these factors, technology, production, training, tactics, and strategy, that made the P-51 Mustang one of the most important and most successful fighters of World War II. When we see that distinctive silhouette with the long nose and the belly scoop, when we hear the sound of the Merlin engine, we are reminded of the young men who flew these aircraft into combat, of the missions they flew over the heart of Nazi Germany, of the victories they won in the air, and of how they helped to win the war and preserve freedom.